Hey Travis, thanks for doing another one of these with me, man.
Yeah, man, happy to jump on and chat about DriveWorks.
Yeah, yeah, cool. I mean, DriveWorks has been a topic of conversation for me a lot more lately, although it seems like it's been around in SolidWorks like probably ever since I started using SolidWorks. I don't know. It was there
I think
in when I graduated college, 2009. It was
I
there.
think it's been around since 2001. So yeah, it's a pretty well-established tool.
Okay, yeah, I started in 2005 with SolidWorks, so it's been there the whole time. Um, and yeah, last time we delved into it pretty good. I mean, if there's some folks checking this one out, there is a video that doesn't have 2.0 in the title, Automating Solver to DriveWorks. You guys can check that out. And I wanted to see a little more in-depth stuff, a little more hands-on stuff. So Travis, that's why I asked you to come back and show me more of the interface. But honestly, since then, I've done some AI events with MLC, and uh, I was surprised at how many people didn't know about DriveWorks because the two topics that really keep coming up, we're trying to figure out, right, like how are people using AI in engineering really? Like we all have ideas of what it could be, what we want it to be, but like who's using it successfully right now? And the initial questions I usually get are about automation inside SolidWorks. Like, oh, can SolidWorks predict I'm going to do something? Can it automate something? And I usually end up going, well, yeah, but it's not really AI the way we think about it. It's like, yeah, we could automate all your stuff right now with some custom programming, with some macros, or just fancy use of drawing templates to automatically be drawings. Then the other way I see it used is folks doing programming and like coding projects that who maybe would have never done that in the past. Like they're not programmers, but they're like, we need a tool that basically automates something. They use AI to build it, and then they go offline with that tool, and they're using it then independent of AI. And so I've been telling those guys about DriveWorks when these come up, and I'm surprised at how many people don't know it because I'm like, hey, it's the automation tool of SolidWorks basically that's already there. Oh, I don't hear you right now, Travis. Oh, you know what? I think you got your mute on. There you
Sorry, I was muted. There's some shop work going on with the 3D printing guys, but
go.
um, yeah, I think when people talk about AI, especially these days, they're thinking about typing in a simple prompt and getting a very automated kind of formal response. When you think about SolidWorks, I think people kind of think the same thing. Like I want to be able to kind of enter a prompt and get some sort of output. And really, that's something DriveWorks can do. It's not necessarily an AI tool, but what we're doing is we're building in some logic so that you can have kind of simple, easy to understand inputs with very complex outputs for production and manufacturing.
Okay.
Um, and yeah, I think a lot of people just aren't aware of how powerful DriveWorks can be as an automation tool.
Yeah, well, maybe we can look at some of the nuts and bolts of it then, because I think with something like this too, and like any traditional programming project I've done, which I've not done a lot, a little bit. I have when I started using stuff around here, actually for MLC, I grabbed the Python book Automate the Boring Stuff, which I feel like really, is
Nice.
telling. Yeah, it's what you're doing. But for this type of stuff, I want to be really detailed. Like I was making like a lot of PDFs. I needed information in a certain spot. I couldn't have it mess up, or what like AI people would call like a hallucination, right? I couldn't give it any freedom. It's like you need to do exactly this task or fail at it and tell me why you failed. Like no
Yes.
room for error. And I feel like that's probably true of DriveWorks too. Like we need to nail down the details.
Yeah, I think that's where DriveWorks is really offering some benefit over kind of AI in the true sense is with a lot of the AI tools out there, you don't really know what you're going to get as an output, and sometimes you can even ask the same question twice and get a different response. With DriveWorks, that's not the case. We're building in very standardized logic so that we have automated outputs. We're eliminating errors in engineering and design, errors that pop up on the shop floor. We're going to build very predictable output responses just based on logic and DriveWorks. So we can definitely show you how that's done.
Yeah, shoot. Well, maybe we can take a look at some of it. I got your screen over. I'm gonna pull it up because I noticed you've
Cool.
got like a cool little assembly open conveyor, which seems very configurable in size.
Yeah. Anybody that's maybe an existing DriveWorks user has seen this before. This is just kind of a model we go through in training, and it's a really good example because I think it's pretty easy to follow. Certainly, not the limit of what DriveWorks can do, but we can at least kind of introduce you and everybody else to, what it looks like to go in and capture models and write rules and what the basic process looks like.
Yeah, that'd be cool to see a little bit of that. And we talked last time about licensing structure and stuff. That was kind of in our last
hmm
video. But what license are you using for something like this?
I'm using DriveWorks Pro. Most of what I'm going to show here, this could be done in DriveWorks Solo or even Express to some extent. Pro is just kind of what I work in on a day-to-day basis, but I'm just running a DriveWorks administrator license, and we'll kind of show you what it looks like to use that in the SOLIDWORKS interface and the standalone administrator interface.
Okay, cool. So you got this assembly here, and like, do you have anything already captured into DriveWorks?
Yeah, I do have quite a bit captured already. This is kind of a completed project that I just trimmed a couple things out of. So over on the right-hand side, this is the DriveWorks Pro add-in, and this is where we do a lot of our SolidWorks operations to go capture models or capture our assembly structure. And that's kind of what you're seeing here is, this is the assembly structure that I've captured to say, these are the models that I want to be able to change. So not everything gets captured, things like brackets and hardware, we don't need to capture those. Nothing's going to be changing throughout our configurations. But for things like, these beams along the sides or the end plates or the leg supports, those are all containing dimensions and properties that we want to be able to modify. So kind of step one is to go in here and just kind of check the box to say, this is what I want to be able to control. The example I think we'll use here is this roller frame beam left. That's just one of these side beams here that we want to be able to change the length of and a couple other things that we'll dive into. So once we've got our assembly structure captured, really from there, it's just kind of diving into each model to capture dimensions, features, custom properties. So if I wanted to capture some parameters for this beam, we would just double click on it. And it's going to go ahead and open up to that model. And then it starts to change the little add-in interface on the side to be able to capture different things that we want to control.
Okay.
So only a handful of things here that we would probably capture for this, but I'll show you just how easy it is. If we wanted to go capture like the overall length of this beam to be able to drive it, I could just double click, and this is kind of a standard SolidWorks function. It'll show me some of those dimensions out in the graphics area. I'm going to select this overall length dimension. And over here on the right, you'll see that it's actually populated this little address bar. So this is just your standard SolidWorks dimension name. This one happened to be renamed to frame length. And it's gone ahead and taken that as what's called an alias. And just to give you a little, insight as to why there's an alias. As you know, the standard SolidWorks naming scheme for sketch dimensions would be something like, D1 at sketch 6,
Yeah.
which doesn't really mean much to us later on when we go try to write rules for this stuff. So we just want to give it kind of a recognizable name, in this case, frame length. That'll be very obvious later on when we want to write a rule for what should happen to that dimension.
Okay.
So I'll go ahead and hit add, and that's now going to show up under this dimensions folder as a captured dimension. And then from here, we can just kind of repeat that process for a couple more things. Maybe something else I want to capture would be like all of these slots. These are where each one of those rollers are going to index. And as that frame length changes, we want to be able to change and control the number of slots so that we have the right number of rollers. And for that, we could go double click on the pattern itself. And these are always a little tricky to find sometimes, but you'll see a dimension pop out that says, in this case, our slot separations. So that's just your instant spacing in your pattern. And then there'll be one more out there that we would want to capture as well. And this one's always a little tricky to find.
I noticed you use Instant 3D, which is turned on by default in SolidWorks. So like when you click on something one time, dimensions pop out. I usually turn that off. It's on the features command manager, so I have to double click. Actually, you've got it off, so maybe you are double clicking.
I am
Oh, you're
double
double
clicking.
clicking.
Yeah,
Okay.
yeah.
I was like,
That's actually something we.
yeah, I turn it off,
You're
man.
like, how's he doing that? Yeah, yeah. I'm the same way. I keep it turned off, and that's something we actually cover in the first lesson of training for DriveWorks is kind of different settings in SolidWorks that you want to have turned on or off, and we do keep Instant 3D turned off so that we can select these without having that little
Oh, that small box.
dialog box become active. Yeah,
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 I like
exactly.
it off. I mean, I used SolidWorks before Instant 3D was there, and there's so much stuff going on in the interface anyways. The other kind of like interface trick I usually show people when you're doing equations or stuff like this is that the dimensions in blue were typed in while you did a feature, and the black dimensions are actually
Yep.
like sketched, dimensions in a sketch.
Yeah. So like these would be sketch dimensions here versus things that show up in the property manager for like fillets or linear patterns. You got it.
Yeah, cool.
So yeah, I went ahead and captured the slot separation there. And then there should have been one more for our linear pattern, and that would have been our instance count, which is always really hard to find in this model because
It's
it's
blue.
blue, just like the model. Yeah,
Yeah,
there it is. So you'll see this little 22 kind of floating here, and that one's just going to be the instance count. So we'll capture that as well.
cool. Can you rename the dimension when you capture it? If it was like D1 at sketch 2, can you rename it right there in the DriveWorks panel?
Yeah, yeah. So if
Okay.
I go show you one that maybe hasn't been renamed, so like D1 at sketch 36, just kind of another random dimension, you could name it whatever you
Right
want.
there. Okay.
Um,
Cool.
Yeah, so that's typically something that we'll go through is just apply, various naming conventions that make sense. So we've captured a couple dimensions that we can drive. I'm also going to capture a feature as well. So obviously for dimensions, we're going to be changing the value of that dimension. If we capture a feature directly, like this side rail mounts feature, typically what we're doing here is we're doing a suppress or unsuppress. So you can kind of imagine
Hmm.
that these would be for some sort of a side rail that will allow the customer to either include or exclude. If they're not going to include the side rail, we don't need the mounting holes for it either. So we're going to capture just this cut feature that we're going to suppress or unsuppress based on the user's choice. So once we've got all of those, we can go ahead and hit the little save button here in the add-in, and then that's kind of saved all of our captured parameters. And you would really just kind of repeat that process throughout various models. There's actually one other thing I wanted to capture here. So I'm going to scroll down here to the bottom. You'll see there's
Oh
these little
yeah.
tabs here for various things you can capture. One more that I want to capture from this model would be a custom property. And this is kind of a special one. You can capture all of your standard custom properties, but there's a couple that you can add, like DW color with a very specific name. And if you've got a custom property with that name, you can control things like the color of the model. Um, Another one would be DW material. So if you drive a material value into that property, or in this case, an RGB value into that property, you can control either the appearance or the material directly from
Oh,
DriveWorks. So we'll go ahead and capture that as well. Um, and then while we're in here, I'll show you maybe one other thing. File formats is a really cool one. These are all of the other file formats that you can have DriveWorks output for a specific model. So it can do the conversion to Parasolid, Step, STL, DXF for your sheet metal parts. If you want to have a flat pattern created every time you generate this model, you can basically, choose here to export that. So if I wanted a DXF to be exported, I could just change this to yes, and now it's going to spit out the SOLIDWORKS model and a DXF flat pattern at the same time.
okay. And I can see it's automating SolidWorks to do that. It's using the SolidWorks. Then you'll see SolidWorks like open the file, save the format, put it where it goes. Okay.
Exactly. Yep. And we'll show that here at the end. We'll actually have it run through and generate some outputs for us.
Cool.
So I'm going to go ahead and hit save here, and you can kind of use your imagination on just repeating that process for other files in this assembly file set. But for now, we'll go ahead and jump over to DriveWorks Administrator, which is a standalone application. And this is kind of where all the magic happens. So step one is let's go capture, at least kind of an initial set of parameters that we want to be able to drive from our SOLIDWORKS models. Now what we'll do is we'll go set up really two things inside of the DriveWorks project itself. We'll create a user interface to give some interaction and some selection options for configuring our conveyor. And then we'll write rules to kind of take what the user has specified for the conveyor they want and tie that into the dimensions that we previously captured.
Cool. And this interface, this is the DriveWorks Pro license, right?
Yep, this is DriveWorks Pro Administrator is what we're looking at right
Okay,
here.
I got you.
And so there's quite a bit that you'll see over here on the left, but it's pretty easy to understand once you've had an hour or two to play around in it. Where I'm at right now is in the form designer, And you can kind of see a little preview of what this form is going to look like. But if I dive over to one of the specific forms itself, you can see where we've added some controls to be able to
Hmm.
have like a slider for conveyor length, width, height. All of these are just grabbed off of this top
I
toolbar.
got you.
So
It's
nothing too
like building
crazy. I mean, if
a
I wanted to,
PDM data card or something.
it's very similar, yeah. So if I wanted to add a new slider, I would just click the slider button, give that control a name, hit OK, and then now I've got a new control that I can kind of reposition. And then each one of these controls also has properties over here on the right that you can adjust as well. And I'll talk about a couple of these. So specifically, I'll talk about conveyor length because that's really the one that's going to affect this beam we just captured. Um, Once I had this control on here, we want to have some rule sets to kind of limit what people can select. We don't want it to be the Wild West of kind of go choose anything. Certainly, we want to have in this case like a minimum and maximum value that users can select from. So on that slider, I can go set the maximum and minimum properties just to ensure that we're not making things too big or too small that we can't actually manufacture.
Sure, yeah, that makes
And
sense.
then along with that, there's all sorts of fancy, appearance properties and fun things that we can change to make it look really
Hmm.
nice. So we'll come back and maybe look at some other rule options later that are a little more complex. But for now, that's kind of really what we need to be able to drive that beam that we just looked at.
Okay. Yeah, I think I'm with you. You captured those. How did you link? I might have just missed this, but how did you link the actual dimension conveyor length to that slider?
Yeah, that's kind of the next thing
Oh,
that we'll
okay.
do. So right now it's just named conveyor length.
Gotcha.
But what we'll do from here is we'll go down to model rules. And inside of model rules, these are basically all of the models that we've captured. And we'll see the one here that we just captured, which is roller frame beam left. There are a couple of other ones. So when we have just that model selected, these are the rules that are available to us. So you'll see the frame length dimension, our instant spacing, and quantity counts. Our side rail mount feature, our DW color property, and then every model is going to have these first three as well. So this would be file name, file path, and then an option to write some rules based on configurations. So kind of nice that it whittles it down to just what you've captured. You're not looking at a ton of info that's hard to digest. So back to your question about how do we tie the slider
Yeah.
into the actual dimension itself, that would be this guy here. So the frame length dimension, we would go ahead and just double click this to write a rule for it. And that's going to go ahead and open up the rule builder. It honestly is a really easy to understand tool. I know you've done a little programming with Python. I somehow scratched and clawed my way through a programming class in college. This is much easier. The whole idea here is that you really don't need to be a programmer. You should really have a fundamental understanding of the engineering knowledge, and then it's just your job to kind of convey that understanding into a really easy to understand. I don't even want to call it a programming language. Syntax maybe is a better word. It's a lot like Excel. So to kind of show you how this would happen, let's say that I wanted to take that slider and whatever value somebody has specified in the slider, I want that same exact value to go right into this dimension. If I
Right.
didn't know anything about the way that rules are written in DriveWorks, they've made it easy enough because over here on the right, there's a tab called controls. And this is going to list me off all of the controls that I've added to my forms. So if I go find that conveyor length control and double click it, it just adds the proper syntax to pull that value from the control.
Okay.
So it says conveyor length return. That's the way that you could type it out manually if you wanted. But that just means that we're essentially returning the value from the control called conveyor length. So whatever we set that slider to, that's what the dimension will be. So pretty darn easy for simple rules like this. And what's cool here is you can actually test this out. So you'll see here, as I write the rule on the values tab, it's showing me the current result. Right now it says 1,000. If I confirm this rule and go back to my form designer and enter what we call test mode, I can actually adjust this slider if I wanted to. And then I could go back to model rules. And if we
Oh,
look at
yeah.
that rule now, it's actually changed. So you can kind of on the fly check your logic if you're doing math or just wanted to make sure that what you've written is actually given the correct output.
Yeah, I'm seeing here, I mean, you have functions up top, you have then the ability to do like constants, variables, put multiple things together. It seems like you could probably do more here than you could in the equations manager
A
with
hundred percent.
SolidWorks.
Yeah,
Yeah.
yeah, absolutely. And I'll maybe show you some examples here. Let's see which one will work best. Let's try our roller quantity, or our slot quantity in this case. Um, so I've already got a variable that we could use for this. Rather than just rewriting it, I'm going to kind of digest it with you. So if I go in here to my variables, and what I'm looking for is called roller quantity. We'll just go ahead and filter out here. So this variable is actually storing a little bit of logic for me. Um, and to kind of show you how we maybe accomplish that, what I'm going to do is I'm going to right click and edit this variable, which will actually show me how it was built. So now we're actually editing the variable that's used in the rule. And this is kind of the first look at maybe a simple function. This one's using a round down function. And so what we're doing is we're rounding down whatever comes after this first parenthesis. And it's actually a little bit of math. We're taking the overall length, more or less, of the conveyor and dividing it by a constant called roller gap. And roller gap is just kind of what we thought of as our ideal spacing. Like if
Yeah.
we could use any roller spacing, we want it to be 68 millimeters. So we wrote that as a constant that we could just reuse throughout the project. Um, I think you probably can guess at how constants are used. They just store static values that we can reuse over and over.
Yeah,
So,
this is pretty interesting, 'cause I thought like in my model, I would need to build the intelligence into the pattern so that as things get longer or shorter, we have the right number there, or like equation usage for like minimum distance to edge to prevent bolt tear out. But it looks like you could do all that here.
yeah, and we that's a great point. We actually prefer to do it in DriveWorks. I
Really?
always kind of encourage people to strip out any existing equations or complex logic from their SolidWorks projects, just because it makes it harder to maintain. If you've got two different places where you've got some
Sure.
automation, you
Yeah.
kind of have to do a little bit of thinking about, man, where did I write that? Where's it being controlled? It's a lot easier to just do it all in DriveWorks, and you get a lot more functionality. So you'd kind of pointed out, I've got a functions button up here at the top left. These are all the functions that are available to use in DriveWorks. It's a lot,
Yeah.
right? There's a bunch in here that I probably never used. But long story short, you've got a lot more functionality and kind of power built into DriveWorks. So it usually makes more sense to just kind of have it in one place.
That's really cool. Yeah, 'cause I always thought like you know, example conveyor or like, stairs or something where you go, oh, we're going to build it larger and smaller, we're going to fit in different spots, that I need to have it done in SolidWorks to the point where it's going to fit all those places and update exactly like I want. But you actually don't. You just need to have like one model built.
Yep.
Yeah, that's kind of it. And then you can go DriveWorks.
Yeah, and the cool thing too about building your models kind of simple in SolidWorks is in some cases they're almost less likely to break. You can do all the math and do all that stuff in DriveWorks to make sure the math looks good and not accidentally run into
Honestly, you
issues
probably have a
with
better performance too because you don't have that in the rebuild time of SolidWorks anymore.
100%. So you're not having to worry about rebuild times. You also don't have to worry about in context relationships. So if you're trying to
Yeah.
link equations between assemblies and parts, that gets kind of difficult to maintain. So yeah, you're just kind of passing static values, all the way down. And honestly, DriveWorks is probably better at handling that math. So yeah, it's a great point about rebuild times as well.
Okay. Cool. Yeah, that's kind of eye-opening for me. Uh, yeah, a lot of the logic that I'm doing in SolidWorks could actually be stripped out. That's interesting.
Yeah, I see people do some pretty complex stuff or push the limits of what SolidWorks can do with the
For
logic. And as
sure.
soon as we show them this, they're like, "Oh my gosh, I wish I would have used this, way in advance."
Yeah.
Um, just to show you real quick too, you mentioned that function option. What's cool too about a lot of these, or at least a handful of them, is there are some wizards that can kind of help you out. So under this drop down are kind of some quick, tool tips. We'll maybe talk about like if
Ah.
statements later, but let's say you've never written an if statement before, or you don't know exactly what format DriveWorks is going to want. If you were to select this, it'll actually bring a little wizard here where you can write your conditions and then your, true false outputs, and then it'll format it all for you and kind of build in the parentheses and the commas.
Yeah,
Um,
that's pretty nice. It's pretty easy for it. Have you ever used the VLOOKUP function in
yeah,
DriveWorks? Yeah?
yeah. I'll show you an example
Wow.
of it here in a second. Um,
Okay.
we use it a lot for sure.
I use it a lot in
Um,
Excel.
no, it's super handy. And also, if you hover over any of these functions in the rule builder, you'll see here that it shows you like a little tooltip of the format that's expected. Um, so I'll use this too if I'm going back, looking at a rule that I previously wrote. It kind of gives you just an idea of what's going on.
Mm.
So that is our round down function there. So that's kind of how we achieved this roller quantity value. I just know from doing this a million times that we also need a +1 here. Not really important for what we're talking about, but that kind of goes into like your seed instance versus your pattern
Mm.
instances.
Sure.
So we're just kind of taking that into account as well. So we've got our slot quantity, and then I'll show you the slot separation. We'll add this just to make sure that this works a little bit later on. This one's also coming from an existing variable that we may take a look at. This one's going to be roller separation. And if we just edit this variable real quick, this one is just recalculating our separation. And long story short, we know our ideal separation was 68 millimeters. We kind of captured that in a constant. But we also know that if we're allowing somebody to kind of change the length of this conveyor in 1 millimeter increments, they're going to land on a value that's not divisible by 68. So we've got to figure out a way to account for that. And that's kind of what we did here is we calculated kind of the closest that we could get to that. I won't go way down into the weeds, but we kind of took what our calculated roller quantity was and our usable space, and then we just did a little bit more math, rounded down, and this is kind of telling us, hey, 69 is what our spacing is going to have to be here, just to get an
Nice.
even number of rollers.
Yeah.
So that's all we needed there. Man, do you want to keep going through and just knock out the side rail mount and the color, or are there any other kind of questions you had about rules that we want to look at?
Man, I don't know. I feel like I have a really good understanding, actually. I mean, I've seen them captured before. I don't think I'd seen as much in linking and like writing the rules like you just did,
Okay,
but I feel pretty good about that. Like I think I see how the side rail mount features would work.
cool. Let me show you
Yeah.
DW color because you had asked about using the VLOOKUP, and I did
Yeah.
want to point out the use of tables in DriveWorks because I think it's a really useful function. So for DW color, kind of the idea here, let me just paint the full picture. If we go back to our form, what we've got on the form is we've got a drop down where somebody can select from a large number of colors, right? Just all sorts of different colors that they can choose from on their conveyor. And what ultimately has to happen is we need to pass an RGB value down to that DW color custom property. That's kind of how
Okay.
SOLIDWORKS is going to actually paint the appropriate color on our models. I don't want people choosing RGB values because nobody's going to know what value to choose, and it'll be
No
kind
way.
of a guessing game. So instead, we're going to give them the list of colors, and then we're going to find and pass down the appropriate value, and we'll do that through tables. So over here in the tables category, we just created a simple table, and we actually just pasted these values from Excel. So we've got one column with all the colors, and we've got one column with all of the associated RGB values, and we're just going to do a VLOOKUP to grab the
Yeah,
one
I
we
can
need.
see where you're going with that. I got you.
Yeah, so now over
Yeah.
here in our DW color property, go ahead and write a rule. And I'll actually use the rule builder for this. So I'll do VLOOKUP, and the value I want to look up is the color that the user selected. So on
Hmm.
my controls form, I'm going to go find the frame color. So we've got a drop down called frame color. I'm going to go ahead and double click that, and it's going to put it into this little wizard as the lookup value. Next, we're going to tell it what table to go look it up in. I've only got one table right now. It's called colors. And then the color that, or the column rather, that we want to return is the RGB column. and we're going to tell it to do an exact match on all
Oh
of
my
this.
God. This is easier than Excel.
It's way easier.
Way easier.
We'll hit finish and it'll write it all out for me. It's got it, you know, appropriately formatted. And then again, if we look at the values column, it'll basically tell me right now somebody's got red selected and the output result is 255.00, which is perfect. So we know that's good.
Heck yeah. Now,
Easy as that.
dude, I have one question on your form. Where'd you get those images of the thing? Are those out of like Visualize?
I actually don't know where these came from. DriveWorks provides them as part of the training content, but Visualize would be a perfect place to get kind of a really
You
high
just make,
quality rendering.
yeah.
Yeah.
Okay.
Um, and I guess just to give you a little insight as to what's going on here, these images that we're kind of picking from, these are actually controls that you can interact with. So this is a checkbox control, believe it or not.
Hmm.
So you'll see as it's checked and unchecked, the image changes. And that's just done through properties over here. So there's a picture that can show when it's not checked and another picture that can show when it is checked.
Oh, cool.
So we're kind of given some nice visual interaction just by swapping out pictures as it's selected or unselected. And same thing here with these option buttons. So as you pick between two different options, it toggles back and forth between kind of a somewhat transparent image and one that's fully rendered.
Yeah. Very nice. So when the end user is running this, do they do it in this interface or does that image show up in SolidWorks?
You can do it from two different places. So it's really going to come down to whether or not you have a SolidWorks license. So if you're a SolidWorks user, you may decide to run this in the SolidWorks add-in. If you're not a SolidWorks user, maybe you're a sales guy, you could run it in kind of the standalone interface down here in what we call Specification Explorer. So it could run
Specification.
right here in DriveWorks
Oh, okay.
Administrator. Um, or if I'm inside of SolidWorks, I can actually go up here into the add-in and hit run, and it'll run here as well.
Oh, nice.
And you can see it actually has a little bit of dynamic scaling control that kind of repositions some things just based on the size of the window that's available.
Yeah, that's cool. And is this one of those where if you change the conveyor length, your image of the conveyor changes on the right?
We don't have it set up here, but that's 100% possible. So you could have a dynamic 3D preview that's actually changing over here on the right. This one's just kind of a static image right now.
Yeah.
But yeah, that would be a pretty cool option that you could certainly build in with DriveWorks. Would just be a live preview of what you're configuring.
Yeah, I've seen that definitely on like the DriveWorks Live website. It does always look slick when they get longer. And honestly, I think it's kind of like, gosh, I was doing it in PowerPoint the other day where you could just take two 3D files, always really the same file, like an STL file,
Hmm.
put it on a PowerPoint slide, you can rotate it around. Then I put it on the next PowerPoint slide, rotate it to a different position, and use the morph transition, and it just magically, when you change slides, it goes from one to the other. That's kind of how I've seen it presented in terms of DriveWorks before to me as well, where it's like, hey, here's a longer one, here's a shorter one. Graphically, it just kind of morphs from one to the next.
Yeah, it's pretty darn slick. There's a lot of ways you can do this. I mean, for simple changes, I've actually seen people just swap out static images. So, maybe you rendered them in all the available colors or had some, you know, incremental size changes. You're not showing like changes down to the millimeter, but as somebody has maybe jumped up 100 or 200 millimeters, you're just slightly increasing the size. So we're just going to swap out to the next
The next
image
image.
that's closest. But the
Yeah.
3D previews give you full control. You can either swap out 3D models based on what they've selected, or you can actually drive kind of the scaling or the dimensions of a 3D model in the preview. Um, I don't know if we want to go too far down that rabbit hole. Maybe we'll save it for another video,
Yeah,
but
you might
there's a
save it for
lot of
another.
stuff you can do.
I mean, this is really what I wanted to see. I feel like you've taken me from, all the way to the sketch level through building rules to see this stuff. And I think I was most impressed today with capabilities for equations and like intelligence that are honestly easier and more powerful than what I'm using right now in SolidWorks, like in equations. Um, I mean, if I was going to ask you more, and we've used up some time, so I think maybe if we do another one down the road, but if I was going to ask you more stuff, I'd want to see things DriveWorks can do without SolidWorks at this point, because I know it can
Yeah,
do tricks that SolidWorks can't now.
it can do a lot of cool things. It's really, I refer to it as like a rules engine these days. Yes, it does a lot with SolidWorks, but there's so many things you can do outside of SolidWorks because all these rules can still apply to non-SolidWorks things like exporting, information to an Excel sheet or a Word document. So if there's documentation you need to automate, you can actually drive the text or the values in an Excel sheet to create quotes or, a Word document to create maybe a statement of work or an order form, or even just
Mm,
output data to another system like ERP or, a database that you might have. So yeah, there's some really
very
neat things that you can
interesting.
do just with the ability to manipulate all this data in a really easy to understand way.
Can you run SQL queries from DriveWorks?
Yeah, we do it all the time. So you can
Okay.
you can query data out of SQL, and you can also natively write and insert data into SQL. You can run um, all sorts of cool things. I hate to even start
Okay, yeah,
talking
yeah.
about it, but
I'm
yeah,
gonna
it's very powerful with databases and what you can do.
Cool. I'm gonna say, yeah, put a pin in that, dude. If we get together again sometime down the road, I mean, this my calendar, end of year calendar's getting nuts, but I want to pick another time because maybe we should just look at DriveWorks without SolidWorks at all.
I think it'd be
I'm
fun.
immediately thinking of PDM and other document things, but yeah, this is pretty cool.
Yeah. Well, if you want, we can kind of show what it looks like to actually run this project now that we wrote those rules. We
Yeah, I
can
don't
just
want to
go ahead
miss
and
that.
yeah, it's kind of the coolest part. So I've already got this project open here. So first thing is I'm going to go ahead and enter in an order number. We'll just kind of make something up here. Um, we'll specify a conveyor length. You'll notice down at the bottom too, we've got kind of some dynamic things changing. In the bottom
Hmm.
left, this is a smart part number that's kind of updating based on our conveyor selections. So that's updating as well as our price. We'll save some of that stuff maybe for another discussion, but we'll go ahead and make a couple of changes here, make a couple of selections. I've got some options for including like our flat pattern DXF if we want it. Same thing with maybe a PDF output for all of our drawings. On our options tab, we'll go ahead and choose kind of a new color here, something crazy. Let's see what we got. Maybe steel. Well, we'll choose spring green, something obvious. We can choose independently whether we want a left or right side rail or if we want a side rail on both sides. I think we'll go ahead and choose just one side. Got our little checkbox here for our elevated side rails that we'll go ahead and enable. And then we'll stick with our roller bed. We haven't talked about dynamic model replacement yet, but we'll maybe save that for another example and show you guys the belt bed. And then I'm going to go ahead and hit generate. And I don't have this project currently set up to automatically start generating. So there's kind of one last step I've got to do. Just go up here to this generate models button and it'll show me any specifications that are currently pending generation.
Okay,
So there's
so
our
that's the
order
one we
number.
just did. I got
Yep.
you.
And then we'll hit generate. And what it's going to do is it's going to go ahead and, create copies of all the models that have not been previously generated. And then it's going to open each one of those up and just start running through and changing all the parameters. So we see some sizes change, we see the color change. We'll see, features maybe disappear. And then once it's done with, all the models, we'll see it start to jump into drawings as well.
That's amazing. Yeah, this is the payoff for sure. Yeah, you could definitely. I'm glad we're showing the nuts and bolts of this because this would be marketed as AI in a heartbeat.
Yeah. Yeah. If you didn't know how it was set up, you'd think it's just, magic and certainly leveraging maybe some tools that are difficult to understand, but it's really not. Kind of the way
Yeah,
that DriveWorks has posed this is they've taken care of all the difficult stuff, which is understanding the SolidWorks API and how to access it and drive it. And it's really down to you to just kind of plug in, your engineering data and make it work.
hey, now on some of these, I see there's parts that are being reused because they're unchanged,
Mhm.
and then there's copies of parts being made. Would you have an option to say if you just change length and color to just use a configuration of that part instead of making a copy of the part?
You can. So within some of the rules that you write, if you've got a file that has multiple configurations, you can tell it which configuration to use. And that's something we actually do with these side rails. The side rail assembly itself has two configurations for tall and short. So whenever we're picking between those two options, we're actually just writing a rule that calls out which configuration is going to be
Cool.
used in the file that we're reusing.
Nice.
Yeah, pretty cool.
Yeah.
This is also another huge thing right here is reporting. I'm sure as somebody who's done their own programming, trying to troubleshoot is incredibly difficult. If you're doing your own, programming in, Python or C Sharp. Here you actually get full reports at several different levels throughout the project. This is called the model generation report. So we can actually see what's happened with each model. Gives us a nice little entry count for things that were successful, maybe had a warning or had an error. So as you're kind of doing your development, you can kind of look through this, and sure enough, there is one that does have an error. So if we were trying to figure out what happened here, we could double click on that, and it gives us kind of a full breakdown
Oh.
of all the steps that were taken. And I knew this one would pop up just because I haven't completed this yet, but I was trying to rescale and position a drawing view that doesn't currently exist. So it's trying to rescale and position something called drawing view 2. We went and looked at that drawing. There's just not a view called drawing view 2. So in this case, that's expected, but it's nice to kind of get a full breakdown each time you run this of what took place and maybe what needs to be investigated.
Yeah, it looks like it did the rest of it. You're just gonna be missing like one view that you expected.
Yeah,
You
yeah.
made the
The
drawing.
view, yeah, all the views that should have been placed were. I've just got kind of a special task I applied as an example. I guess for kind of another project I'm working on.
Yeah,
So
yeah, cool.
all of this is expected, nothing to fix. But nonetheless, nice to have some reassurance that it wasn't anything important.
Yeah. Yeah, I mean, you get right to it. That's cool, man.
Yeah, yeah, pretty cool. So ultimately it output everything we needed and placed it in the right spots. But if we wanted to go look at what that final assembly looked at, we could just go ahead and pop it
Oh
open
yeah, it's
here.
in your recent docs, of course.
Yep, looks
Dang, that's
good.
so nice. Yeah,
Everything's in the right spot.
that is pretty amazing.
Ready, ready to go.
Yeah. Yeah, I don't think
So
I can think of anything that you couldn't automate in SOLIDWORKS really with this.
yeah, I mean, really, you can do some insanely powerful things, and maybe we'll just have a session one day when we just look at some wild, wild stuff that I've seen, or find some crazy examples that are hard to believe. But for 90% of what people do out there, it's pretty straightforward to get a lot of this automated.
Yeah, that's cool. Well, hey man, I appreciate your time again. I'm gonna use more of it in the future to pull onto this. So, thanks
I'd
for
love
showing me all
to.
this.
Yeah.
Cool. Yeah,
Hard to believe we've already been on here for 40 something minutes. It goes by quick,
I
but
know.
we're just kind of scratching the surface.
This is obviously a really fun program, so we'll do that in the future. I might have you come back. I want to show you some FlowSim stuff because I use FlowSim like you use DriveWorks. I feel like I really enjoy it, so I might flip the chair on you one day if that's cool.
Yeah, absolutely. I'd love to pick your brain on what FlowSim can do.
Heck yeah, man.